Good afternoon, and welcome to our webinar. My name is Jim Colari. I'm the editorial director of Plastics Technology Magazine, and I will be your moderator. The presentation is titled Decorating Plastics, Label and Packaging Solutions, and our speaker is Roman Arts, Technical Account Manager for Inland Packaging. Roman has been with Inland Packaging for 31 years. He received his degree in UW-La Crosse in secondary education. Prior to joining the Inland team, Roman taught at local high schools. With Inland, Roman has had varying roles within the sales and R&D teams. As he enters the latter half of his career, things have come full circle as he dedicates his time to teaching, training, and supporting the development of current and new employees. Roman was instrumental in not only getting Inland into the in-mold label market, but in helping them gain with the position of the market share leader in North America in IML. Please feel free to send questions at any point during Roman's presentation. Simply detach the questions panel from the panel on the right-hand side of your screen and type in your question. Roman will respond to as many questions as time allows. Now it gives me pleasure to turn the program over to Roman Arts of Inland Packaging.
Thank you, Jim. Through the presentation, there will be a few polls that we'd like to gather some information. So let's start with the first poll here, as we are curious as to what brought you here today. Please select the most appropriate answer as it comes up. Well, I see we're getting some results from the poll. Looks like there's questions. I'm interested in all the decoration options are showing up, and looking to see if there are any new solutions out there. Seem to be the two most questions being asked. So with that idea, let's get started. First, we'll go with the pie chart here that shows the global label demand of the various different label formats. Those label formats include glue applied at 60% of the global demand. And this pie chart, by the way, is from AWA, Alexander Watson Associates, and it is the recent pie chart that was applied for these labels. So we got glue applied at 36%, pressure sensitive at 39%, shrink at 18%, in mold at 2%, and others. In this case, others for us, we were talking about direct print and heat transfer. We'll begin with glue applied labels. By definition, glue applied means that the glue is applied to the label on the labeling machine before the label is applied to the container. Now, historically, the greatest volume of labels globally has been the glue applied. But until recent years, within the last 2 years or so, that volume has declined with other label formats, particularly pressure sensitive, because if you noticed in that pie chart, that is now a higher percentage, have overtaken glue applied. And also to that, then, the others, including shrink, have increased, and we're seeing, as I said, the glue applied kind of level out now. Glue applied label substrates for plastic containers include both a variety of labeling papers that includes wet strength papers, oil and grease resistant papers, metallized papers, and specialty or what is called craft papers. And the plastic substrates available are dominated by polyprop films. And those films for labels can be offered in clear, white, and metallized options. We'll look at the label application types for glue applied labels. Includes two formats. First, roll-fed labels. These labels are printed on master rolls of multiple lanes of continuous labels. And then the master roll is slid down to individual continuous label rolls. These labels are then cut from the roll on the applicator, and glue is applied when the label is then applied to the container. Generally, roll-fed labels are full wrap, meaning that the label wraps completely around the container. Roll-fed glue-applied labels are most commonly used for very high-volume carbonated soft drinks, as an example. The other glue-applied style is known as cut and stack, where multiple labels are printed on large press sheets and then cut into individual labels and stacked in bundles to be applied on high-speed labeling equipment. We produce this product type across many different markets. Cut and stack labels can either be square cut or die cut, and can either be spot labels or full wrap labels. Square cut and die cut spot labels are very typical for plastic and glass bottled beverages. For example, beer and soda, and then also for things like salad dressings. Full wrap cut and stack labels are very common for plastic containers. Examples of this would be bottled water, juices, and teas, and bottles for a variety of household cleaning solutions, and other containers as well. Now, there are two types of adhesives that are used for glue applied. First is cold glue. Much like a wallpaper paste, it's commonly used in the cut and stack application for the die cut or square cut paper labels on glass and plastic containers. The other is hot melt. This adhesive is similar to what is used in hot glue guns, and it's commonly used for paper and film square cut or roll fed full wrap labels on plastic, glass, and metal containers, including non-smooth surfaces like ribbed water or juice labels bottled. Glue applied labels are considered secondary packaging since they are not permanently bonded to the container, and or if the type of container's labels are not stackable within one another. Compliancy here then is not as stringent as other types of packaging and labeling, and we are compliant with indirect food contact with inks and substrates for all of our options. Glue applied labels are considered the lowest cost label option, and glue applied labeling equipment, on the other hand, can get very expensive for high-speed labeling applications of over 1,000 parts or bottles per minute. When we talk about recyclability, glue applied labels are made of paper or polypropylene and are both very recyclable friendly materials. The next label type we'll take a look at is pressure sensitive, or otherwise known as PSL. As I said earlier, within the last 2 or 3 years, pressure sensitive labels have overtaken glue applied labels in the global annual volume. Why is this so? Well, there's been a lot more choices of constructions offered now and on thinner materials. And there's also been interest, of course, in no label look packaging. Also, PSL application equipment has run at more and more higher speeds, and there's also ease of application cleanup with glue applied versus glue applied labels, Finished PS labels are similar to a sticker and are supplied in roll form, as most automated application machines require single rolls of labels on rolls with specified roll and core diameters. Because of how the PS labels are made, all PS labels must be die cut, even if they are square cut in shape. PS labels are predominantly pre-constructed materials that will include the label face stock, which uses similar label papers or polyprop film substrates as used in the glue applied labels, but with the addition of the adhesive being pre-applied to the backside of the face stock, and then covered with a siliconized liner, which can either be paper or film. Now, typically, a paper liner will be less expensive than the film liners, but film liners are often necessary for high-speed labeling or when that no-label look pressure-sensitive label is required. Now, PSL pre-constructed material runs through the presses and is surface printed and then either coated or have an overlaminate applied to cover and protect the surface of the label. Once printed, the labels are die cut and the waste or matrix, as it is called, is removed from between the labels. And depending on the press size, multiple rolls of labels can be printed across a master roll, and that matrix is removed. The master roll is then split apart into the individual label rolls for application. Based upon labeling and end-use requirements of the container and the product being labeled, there are many options of substrates, adhesives, which can be permanent, repositionable, or removable, and liner constructions to choose from. So proper construction selection is critical for successful application and end-use conditions when applying PSL. Also, the visual impact of the label can be enhanced with things like foil stamping, textured inks and coatings, for example, gloss matte coatings or a combination, or even tactile feel coatings to produce labels a step above the standard of glue applied labels. When we speak of cost, the PS labels, as I said, are constructed using similar paper or film substrates as glue applied labels as the base material. But there's the added cost of the adhesive and the siliconized liner, which can increase the cost of the PS label to about twice the cost of similar sized glue applied. As we consider the cost for equipment investment, this is where we find a wide variation. PS is the most common entry-level application because literally pressure-sensitive labels can be applied by hand with no equipment necessary. But for high-volume, high-speed labeling applications, those applicators that can apply 1,000 parts per minute or more, equipment can become very expensive. So therefore, equipment can range anywhere from a small table-type PSL applicator to around $200, $300, all the way up to over $1 million or so for high-speed, high-volume applications. When we relook at recyclability, pressure-sensitive label face stocks are made of paper or polypropylene generally, which are both recycle-friendly materials. So the appropriate label and adhesive will allow it to be recycled successfully. PSL has become a very versatile with great variety, and the inks and coatings and substrates used are all manufactured for indirect food contact. Next, in-mold labeling. In-mold labeling, by definition, means the label is pre-applied in the mold as the plastic container is formed. We provide two types: injection mold, or otherwise known as IML, and blow mold, otherwise often referred to as BML. Injection molded uses a female cavity and a male core mold design. Before molding of the part, a label then is robotically placed into the mold cavity and held in place by a static charge until the mold closes and the molten resin is injected into the mold. And then when the mold is opened and the labeled container is removed, another label is then placed into the mold to repeat the process. IML labels can be produced for both cut and stack and roll-fed applications depending upon customer requirements. And it provides 360-degree graphics with high-quality print, and including labeling all sides and bottom of the container as well as the lid if required. For injection IML, with few exceptions, the label substrate must be of the same resin as the molded container so that the label fuses with the plastic resin of the container. For most of the food and non-food IML containers that we apply labels for is most often polypropylene. Now, once applied, the label then becomes an integral part of the container and cannot be removed from the container. Because the label does fuse with the resin and becomes that integral part of the container, for IML food containers, the label, substrate, and container wall must demonstrate that they perform as an active barrier between the inks and coatings on the surface of the label and the specific food product that is going to be placed inside the container. And these barrier properties are validated through migration testing. The other molding application that we provide labels for is blow mold. In blow mold labeling, labels are also inserted into the mold before the part is molded. However, the mold style is a clamshell design with two side-by-side matching mold parts. A label of the same shape and size is placed then in each side of the mold and held in place by vacuum until the mold closes. Unlike injection molding using molten resins, the blow mold uses a preformed tube or parison that is inserted into the mold. And then hot air under high pressure is then blown into the parison, blowing it up much like a balloon and until it fills the shape of the mold, which then activates the adhesive on the backside of both labels. And that's what affixes the label to both sides of the container. Now, label cost for IML generally falls between glue applied and PSL equivalent size labels. Equipment costs are large because equipment costs have to be associated with the molding process itself. So generally, CPGs contract with molders to produce their product in order to alleviate the needs for capital investment into the equipment. As far as recyclability, the vast majority of the in-mold containers require the same polymer in the label to match the substrate. So in-mold label containers of PP or HDPE can be recycled to make things such as landscape orders or drainage culverts, garbage cans, pallets, bed liners, and furniture. In-mold labeling offers a variety of shape possibilities. It has extreme structural integrity and durability. It's good for space optimization, and there's no need for secondary packaging. It's lightweight, and we use FDA-compliant inks and coatings for food and beverages. It's also can be microwavable plastic containers and be HPP and pasteurization tolerable. Following, we'll talk about shrink labels. Shrink labels are printed on films that are able to shrink up to 70%, depending upon the shape of the container. As you can see from some of the examples shown, they can address very unique contour shapes of the bottles or containers. And shrink sleeves are perfect containers to use as they provide 360-degree element design to the package itself, and is the only label type that can provide that 360 billboard for asymmetrical containers. Therefore, it is critical to pre-distort the artwork to the shape of the container. So a lot of planning has to be involved here to take a look at the specific material polymer to be used, the amount of MD and TD shrink percentages needed, the container shape and size, and the type of heat being applied for the shrink all have to be taken into consideration when the pre-distortion of the artwork takes place to ensure that the label will shrink correctly and look satisfactory on the container. Now there's two styles of shrink labels, shrink sleeves and roll-fed shrink. Shrink sleeves often will use TDO materials, roll-fed sleeves will use MDO. And that means in which where's the highest percentage of shrink? Is it across the material, or is it horizontally or vertically in the material? There's a variety of substrates that are used. Shrink sleeves, which are seamed at the printer and converter, use the following substrates: polyvinyl chloride, PETG, oriented polystyrenes, polyolefins, and PLA. And all of these are clear films. And then roll-fed sleeves or roll-fed shrink, which is seamed at the time of the application, those substrates are also polyolefin, PETG, PVC, and OPP in clear, and some options now with OPP in white, and also there's work being done on white for the PETG materials as well. For shrink, labeling can be both pre-filled or post-filled options. And we're seeing a lot of brands choosing shrink over other forms of labels for an array of reasons. Marketing and branding is able to take advantage of that increased 360-degree real estate on the container or bottle. It's very high quality graphics. Inks such as metallics and matte and special soft touch or gloss coatings can be applied. And shrink can be seen as a very durable label option, especially by using the clear film, because the labels are reverse printed on that substrate to the back side of the label, so it allows very good scuff resistance for the label graphics itself. For label cost, shrink factor, type of polymer plays a large role in the overall cost of the label. Equipment costs are similar to pressure sensitive. There are tabletop applications, and there's applicators that run up to 800 to 1,000 containers per minute. Additional costs are for the shrink tunnels, and food packaging shrink containers often use steam tunnels, which can be more expensive than hot air type of shrink tunnels. However, steam tunnels do provide a much more consistent and best fit shrink sleeves to a container shape. Recyclability. Well, historically for recycling, sleeving and seaming materials have been incompatible with the container that they are applied to, particularly if it's PET. The bulk of shrink sleeve label materials are PETG, which does not separate after being applied to a PET bottle when they're recycled. But within the past couple of years, there have been strides and developments made on low-density shrink sleeve films that will separate from the PET container and float in the recycling stream. And traditionally, vast majority of seaming has been done using solvents to weld the seam, which prohibit the sleeve from separating easily from the bottle for recycling. However, recently, there are now seaming adhesives that will break down in the recycling wash, allowing the label to detach more easily from the container. Next, we'll move to heat transfer labels, generally used as a pre-filled application. With heat transfer labels, the graphic image is reverse printed, applying first a layer of adhesive lacquer, the ink layers, and then a protective over lacquer, all printed on a waxed paper release carrier. The application equipment then uses heat and pressure to transfer the image from the liner and affix it onto the container, resulting in another no-label look. When we talk about label cost, heat transfer labels are most commonly printed with rotogravure. So therefore, there's a higher tooling cost for print cylinders and higher press setups charges. So often, the heat transfer labels need high volume print requirements to offset the cost of tooling and press setup. As far as equipment cost, it's dependent upon speed, but it's not traditionally into the millions of dollars for applicators. Finally, we go to direct print. This includes pad printing, inkjet printing, and digital printing technologies. Prints which prints the decoration directly on the container after it is molded. Historically, produced by pad printing, it generally meant 1 to 4 spot colors or simple 4-color process graphics with rather low resolution. But as I said, that either can be directly inline printed after the container is made or staged for offline decoration of a pre-filled containers. With advances made recently with inkjet and digital technologies, however, graphic quality has improved, with one application decorating PET PET bottles up to 600 bottles per minute. But that still is relatively slow decoration process as compared to pre-printed labels being applied at over 1,000 bottles per minute for high volume types of applications. Depending upon the print technology and inks used, direct print is very durable and resistant to scuffing and scratching. An advantage of direct print also does mean eliminating the label substrate and adhesive used in the recycling circle. When you take a look at label cost, then we're only talking about the cost of the container and inks, but we must remember there's that liner that's going to be tossed away. However, it is a slower process, and equipment costs can be rather high for new print technologies like the inkjet and digital ink options. And there is at least one direct print technology out there for PET bottles that is suitable for bottle-to-bottle recycling now, because the hard inks can be removed from the shredded PET, so it's considered very eco-friendly. That brings us then to plastic of flexible packaging, which is truly growing and impeding upon the more traditional label markets. Types of flexible packaging will include flat pouch sachets, stick packs, vertical or horizontal form fill and seal pouches, and stand-up pouches. Flexible packaging is constructed with one or more layers of materials, depending upon the barrier qualities required by the packaged product. Flexible packaging is produced using flexography or digital print technologies, in which graphics are printed on a flat sheet or roll stock and then formed into pouch or sachets. When you talk about packaging costs, the cost of packaging is quite high for flexible packaging due to the need of multiple layered constructions, with each layer possibly being a different resin used, based on the barrier properties that are needed for the product that's going to be packaged with it. However, according to the FPA survey, 60% of consumers are willing to pay more for packaging that offers ease and storability, the ability to reseal, the ease of opening and closing, and the extended shelf life from the flexible packaging. For equipment investments, again, this varies depending upon the product type and the packaging speeds, so that the type of flexible packaging will vary as well. When talking about recyclability, while flexible packaging is considered to have better sustainability than rigid packaging, the area in which there is concerned with FlexPack is the end-of-life stream. Due to the complex constructions that are being used in many of the flexible packaging designs, there are not currently any recycling streams that support its end-of-life environmental impact. However, there are several end-of-life approaches for flexible packaging that are being explored now, and these include systems to delaminate, separate, and recover the film layers. There are several chemical recycling processes being piloted, and anaerobic and pyrolytic waste to energy process are being examined, as well as anaerobic and pyrolytic waste to fuel, waste to chemical, and waste to monomer processes. And then finally, development of mechanically recycled monolayer and coated barrier systems are being looked at. So what's taking a look at flexible packaging? We'd like to take a look at, have you reviewed the solutions for the plastics, and that we're curious, what decoration solution do you currently use? I see the results coming up. A lot of you I see are using glue applied or in mold. And from there, it's pressure sensitive, shrink sleeve, flexible, and direct print are very close together. It's coming in seconds. That's very interesting. So let's take a look then at what's trending. Let's first of all talk about interactive packaging. With the use of digital print technologies for all labeling applications now, interactive or customizable packaging is a trend that we've been seeing in the marketplace on a consistent basis. Consumers love the ability to interact with their packaging or for their packaging to interact with them. Oftentimes, this sort of interaction can provide feedback back to the brand team as well. Customized content is another. For example, the Coke campaign. I'm sure many, if not all of you, are familiar with the Share a Coke campaign, which really drove a lot of hype and excitement about the idea of customized content. We are able to print customized packaging with variable data, such as the Coke labels, with customized content fit for any marketing strategy. Another possibility is digital watermarks. Taking a look at the Wegmans product, for example. Printed digitally or conventionally, an invisible watermark is embedded into the label, which, when scanned by a mobile app, will link users to digital content. When scanned, the content is delivered in real time, and the content can be changed at any time throughout the shelf life of the product. Therefore, things like coupons that can be changed on a weekly basis if that is the request. Recipes, interactive play can all be done with digital watermarking. And then another one would be augmented reality. For example, the 19 Crimes wine bottle that you see there. Augmented reality, or AR, is a mix between the real and the virtual world. The 19 Crimes wine is a perfect example of augmented reality that you can find currently in the marketplace. The consumer can utilize the 19 Crimes app to scan the label, and by hovering the mobile device over the bottle, the character on the label will suddenly come to life, sharing his or her story. So for brands, it's a new way to catch consumers' attention and can make the difference in the purchase decision of the process. Another trend that we are seeing is utilizing multiple label formats. Decoration is becoming more than only a primary label. Multiple label formats, though, can be used in combination based on the needs of the package. For example, a primary label could be a cut and stack or pressure-sensitive label, but oftentimes then a sleeve label is added for tamper evidence closure, as the Wegmans, or adding even more visual impact, as seen with the tamper evident label on the Arizona cold brew product. So another question, are you currently using interactive packaging? We'd love to know. And what type of products would it be? So if you could please select one of the answers, we'd appreciate it. %3 say currently using interactive. There's a big opportunity out there. What else is trending then? Well, certainly there's a lot trending in the plastics industry with discussions about sustainability. So first of all, thin wall, IML, is a discussion point. The demands to create smaller, lighter parts have made thin wall molding one of the most sought after capabilities for an injection molder. Thinner wall sections bring changes in processing requirements, however. It meaning higher pressures and speeds in the molding, faster cooling times, and modifications to part ejection and gating arrangements need to be looked at. These process changes have in turn prompted new considerations for mold, machinery, and part design. Along with that, the substrates as well have been down-gauged and continue to be down-gauged. This is something that Inland and other label suppliers keep an eye on to provide cost savings to the brands. Now, down-gauging may be somewhat of a simple initiative, but it can be implemented to make strides in reducing our carbon footprint. In the past 20 years or so, Inland has down-gauged nearly all of our substrate, some as much as 50% in thickness. For example, shrink materials. It wasn't uncommon not too many years ago that shrink materials would be 60 microns or even heavier. But since then, the down-gauging has taken place, and what was once 60 has become 50, then 45, 40, 35, and now as thin as 30 microns. What we're talking about then is 50% less material being put on into a container, as in the past. The pushes towards sustainability also plays a huge role in seeing the move from rigid or semi-rigid containers to flexible packaging. The advancement in print technology and printing pouches maintains the look and the feel of the product, all the while reducing many of the costs. Because flexible packaging uses less energy than many other forms of packaging. For example, according to the Flexible Packaging Association, making a flexible food pouch requires 75% less energy than making a metal can for the same amount of product and generates only 1/10 of the carbon dioxide emissions. Another way to look at it is that 1.5 pounds of flexible packaging will package the same amount of beverage or liquid food as 50 pounds of glass. Or it would take 26 truckloads of glass jars to transport the same amount of unfilled packaging as one truckload of flexible packaging, with correspondingly dramatic differences then in fuel consumption and greenhouse gas emissions. However, there are some challenges with recycling flexible packaging. But as indicated previously when looking at it, there are many initiatives underway to improve the techniques for recovering flexible packaging that is not currently readily recyclable. With that, ends the conversation, but is there any questions?
Thanks, Roman. We have some time for questions, and a couple of them have already trickled in. There is one question on the recyclability for IML labels. How does the incompatibility between the label and the container material impact the recycling stream? Does it get sorted out or contaminate the end product? And does the same apply for foil-based labels?
That's a good question. For the injection molded labels, what we're doing is in the food arena of packaging, it's polyprop to polyprop. So the substrate is polyprop, the resin is polyprop. It has to be that way because of it needing to fuse to the container and become a part of the part of the container itself, the integral part of the container. So it cannot be used for recycling back into food containers, but the polyprop in mold and label can be recycled into making other items. Mm-hmm. Same way with the HDP containers. There is some labels containers that are HDPE and use a polyprop because they have a similar melt but that would go into the HDPE regrind for HDPE made non-food products.
Okay, thank you. Another question. We are seeing interest in direct printing onto plastic caps and closures. Are you seeing this as well? And how would you compare the economics versus IML?
That's a very good question. Honestly, I don't know what that would involve. We don't see, and I have not seen for quite some time, any interest in IML for caps. And here's the reason why. For cap molding, you're generally talking about molds that are molding 36, 48, 60 caps at a time. And for trying to do injection molding of applying labels in a mold of 60 cavities, that's becomes way too cumbersome, and the robotics for that would be extremely expensive. So I do believe, honestly, that direct print application it would probably be the more suitable as far as the cost for caps than according to the IML.
Okay, that makes sense. Can Inland partner us with a molder?
Absolutely, happy to partner. We have a multitude of molders that we provide labels for, and would be more than happy to give you the list.
With the metallized labels, do they actually contain metal, or is that simply descriptive?
It's aluminum. It's basically it's aluminum dust that is vacuumized onto the surface. Very, very thin, and a lot of it can be incinerated in heat. So it isn't. It definitely cannot be used for reused for food packaging, but the small amount of that of metallized that's on some of these substrates being used and reground and on the part in the container and used as a reused as resins for a non-food container is capable.
Okay, we have a gluing question. Does the glue in these different types of labels pose any recycling risk?
They can, if they are not able to be washed off and deteriorate in the washing baths. That's why there is this change now in looks, as I had indicated, of finding adhesives that are more recyclable compliant, so to speak.
Are you seeing any laser printing for container and or cap decorating?
I have not, to be honest with you.
Okay. On the subject of BML, you mentioned that in BML typically a preform is used. How
Right.
does the BML process adapt to the stretching mechanism of the parison and still achieve a wrinkle-free, defect-free bottle?
It's blowing in a very high pressure, so that it does mold to the smoothness of the wall of the mold.
Okay, you spoke a bit about, I'm sorry, were you finished?
Yes.
Okay. You spoke about shrink sleeves. Does Inland offer warping distortion services, like you mentioned, that are needed for this application?
Absolutely, it's all part of the process. We can do the pre-distortion and then do the pre-distortion, and then through 3D proof, we can show what that pre-distorted label will look like once it is applied and shrunk to the container, so that even before we go to print, the customer will know how that pre-distorted artwork will look once it's shrunk on that container type.
Thank you. What is the difference, and are there different benefits between pressure-sensitive labels and heat transfer or no-look labels?
I'm sorry, what are the advantages?
What is the difference, or are there different benefits between pressure-sensitive labels and heat transfer no-look?
Well, again, they both certainly have their case for use. The thing about heat transfer is that, again, because of the cost, it is rather expensive. So it generally is a very, very high volume type of application to be cost effective. The pressure sensitive initially wasn't a high volume, high speed application process, and has become so that it also can be used for a much more different shaped containers than what I see with direct transfer.
Mm-hmm. Thank you.
Or direct heat transfer.
Does Inland work with APR's design for recycling guides to certify labels?
We have taken a look in that and checked into that. And as a matter of fact, some of our product development people are working with the recycling folks right now about that very thing.
Thank you. Are there inks for direct food contact? And if so, what are the costs?
There are inks for direct food contact. I can be honest with you, we don't do it. Direct food contact inks are very limited to what can be used. Basically, 4-color process. And with direct food contact, you're talking about exactly that the inks will be facing the food product. We don't go into that area, so I guess I'm not a great expert on that.
Okay. Roman, you talked in your presentation about a handful of decorating solutions. Does Inland offer all of these?
What was shown there, we offered everything except the heat transfer and, of course, the direct print. We do not offer those.
Okay. Do you do barrier testing for ink migration?
Absolutely. I mentioned that in the for IML and also for flexible packaging. Migration testing is done.
Okay. I think it might be more popular in Europe, but I've seen it in North America as well, and that is thermoform IML. What do you have to say about that technology, and what type of services do you offer there?
Right now, we do not do thermoform. We've looked at it. It is a third type of molding decoration. It's kind of a hybrid between injection mold, which is using molten resin in the injection mold, and blow mold, which heats the paraffin up to the point where it will activate the heat-activated adhesive of the label. It's kind of in between there. The temperatures for thermoform are in between those two, but the film then is more like the film that's used for TML is more like what's used for injection mold, but thinner. It's high heat and high pressure. to apply the label. And oftentimes the label will need to have pinholes put into it so that it evacuates the air that's trapped between the container and the label to ensure good adhesion to the container by the label. We do not participate in that arena at this time. We've looked at it. We have decided at this point in time to stay with the other two, blow mold and injection.
Okay. And will you be willing to send hard copies, PDFs of this presentation to any attendee who might want one?
Absolutely.
Okay. All right. I don't see any more questions on the panel. So on behalf of Inland Packaging, I'd like to thank Roman for his very informative presentation, and to all of those who registered, attended, and participated in this webinar. This webinar was recorded, and all registrants will soon be receiving a link to the recorded version on our website, ptonline.com. Please feel free to listen again or forward the link to any of your colleagues who could not join us today. Thanks again for attending. Have a good afternoon. Bye.